Today we are going to discuss about discrete and continuous distribution related questions, right? Let's see how to decide which type of distribution can use to solve a particular question, right? This one is related to your tutorial number 4, Fundamentals of Statistics for Technology, tutorial number 4, right? I hope you can find your tutorial and let's see the first question, right? A factory possesses two nut making machines A and B. 5% of the nuts produced by A are defective and 10% of the nuts manufactured by B are defective, right? Here we have two factories, right? A and B, right? Those are producing nuts, right? So machine A, 5% of nuts produced by A is defective, right? 10% of nuts manufactured by B are defective, right? So let's see how to decide which type of discrete or the continuous distribution type we can use for solving this type of questions, right? So let me share the screen. Right, we can see here for a particular machine, there are two outcomes, right? There are two outcomes we can see, right? So, right, we have two types of machines, A and B, right? So machine A that produce 5% of defectives and machine B produce 10% of defectives, right? So for a particular machine, right, for a particular machine, there are two outcomes. One is defective, another one is non-defective, right? We have two outcomes, right? Also, those are independent, right? Those are independent. These two are mutually exclusive or independent, right? Mutually exclusive, right? So therefore, the non-defective items don't depend on defective items. Defective items, defective items are not depend on non-defective items. Therefore, those two events are independent, right? And here we are considering the defective items, right? So our concern is defective items, right? Defective items, right? Question clearly mentioned that we are considering defective items, right? We have two outcomes as defective and non-defective, and those are independent and or mutually exclusive, right? We are considering the defective items, right? So in such kind of situation, we have two outcomes, those are independent and In such kind of situation, we can use binomial distribution. Binomial distribution, right? Also the theory behind that one you studied, right? I will explain how to do that one, these questions, right? We can use binomial distribution, right? We have two outcomes, defective and non-defective, and events are independent or the mutually exclusive, right? Also the probability of success or failure, right? You can see here always the defective percentage is 5%. For B, that is 10%. These are not changing, right? These are constant for each trial, right? So if those conditions are satisfied, we can use binomial distribution, right? This situation is Bernoulli situation, right? Binomial is a special kind of Bernoulli situation, right? Therefore, we can use binomial distribution for solving this type of questions, right? The first one, if 6 nuts manufactured by machine A are selected at random, what is the probability that exactly one of them will be defective, right? So here we are producing part A, right? For machine A, right? The event of interest is number of defective items, right? Number of defective items, right? So the probability of success, what is that? Probability of success is probability of having defective items, right? Defective items, right? You can see here that is 0.05, right? Those information we can take from question, right? So here we are considering number of trials as 6, right? Probability of success is 0.05, right? We have to find the probability X is exactly 1, right? Number of defective items manufactured by machine A is exactly equal to 1, right? That is we want to find, right? Then what is the binomial equation? NCX Px1 minus P n minus x, right? In your exam, you have to clearly write the equation with the correct notations, right? If they don't provide the equation in your question paper, right? If you write the equation correctly in your answer script, they will allocate some marks, right? Otherwise, you will miss that, right? So here they are considering number of trials as 6, right? Probability of success we have, right? Therefore, you can simply substitute values to the equation, right? Right? You can simplify this one. Probability 0.232, right? So part B, if 7 nuts manufactured by machine B, right? Now we are considering machine B, right? Selected at random. What is the probability that at least one of them will be defective, right? For machine B, right? What is the probability of success? Probability of success. Uh, and the probability of success is 0.1, right? Probability of having defective items, right? That is 0.1. So the question says at least one, right? Therefore, the lowest value should be 1 or greater, right? So how we can solve this one? We can simply write 1 minus x is equal to 0, right? Therefore, what is the meaning of that one? X greater than or equal 1. 1, 2, 3, 4, 5, 6, up to 7, right? Here number of trials they have mentioned as 7, right? 1, 2, 3, 4, 5, 6, and 7, right? If you want to take that one, we can simply 1 minus that one, right? 1, 2, 3, 4, 5, 6, 7, right? We are referring 0, 1, 2, 3, 4, 5, 6, 7, right? The question says x greater than or equal 1 means we want to find the total probability of this part, right? Therefore, the probability theory, in the probability theory, we know that the total probability is always equals to 1, right? If we simply subtract from this probability from 1, then we can take the rest of the probability, right? You know that one how to solve, right? So, what is the equation? Is 7, 0, 0.05 into 1 minus 0.05, 7 minus 0, right? Answer should be, you can simplify by using a calculator, right? Or otherwise, right? This is one method, right? Or otherwise, right? You can write this one, right? Or otherwise, you can write this one as like this, right? This is summation, right? We want to take this probability, right? This one x greater than or equal 1, right? From 1 to 7, right? Because what is the maximum number of trials? That is 7, right? The question says that they are considering number of trials as 7, right? So this one should be 7 x into 0.05, 0.05, sorry, this one should be 0.01, right? Answer is this one is okay, right? This one is 1, this one is 1. I made a mistake, right? 7 minus x, right? This one we can solve by using a calculator, right? By using a calculator, you can solve that one, right? So by using these notations also, we can take the same answer, right? Right, or otherwise, or 1 2 up to 7, right? Substitute each and every x values to the equation, right? 0.05, so 0.01, 1 minus 0.01, 7 minus 1 plus 7 to 0.01, 1 minus 0.01, 7 minus 2. Likewise, you have to uh, write each and every situations and sum all the probabilities, right? You can take the same answer. Right. Part C. If two nuts manufactured by machine A and two nuts manufactured by machine B are selected at random. Right. Let's see. Part C. Right. Two nuts from machine A, two nuts from machine B. Right. Are selected at random. What is the probability that exactly two of these four nuts are defective? Right? Let's see that one, how to solve that one, right? So let's try with the tree diagram, right? So we have two machines A and B, right? For machine A, right, we have three possibilities, right? There are no defective items, there are one defective item, there are two defective items, right? Also, for machine B, the same options we have. Zero defectives, only one, two, right? Zero defective, one and two, right? Zero defective, one and two, right? Here, two number of exactly two, right? Exactly two of nuts may be defective, no, right? They have asked about to find that exactly two of these, right? Therefore, this one and these probabilities we want to find. All right. Right. What are the options we have to take, right? Two from A, right? One option, two from A and zero from B, right? This branch is one option, right? Exactly two, no? So, and one from A, right? One from A and one from B, right? This option, right? Because we are going to take two nuts, right? Two nuts should be defective, right? Another option is what? Zero from A, two from B. That is also a one option, right? These three options we can take. right? Other options we can't take, right? Let's see this one. From A, there is no. B also, there is no, right? This option we can't take because the total number of nuts should be 2, exactly 2, right? Some of these two situations are 2. This one also 2, this one also 2, right? If you want to take the probabilities of these branches, you have to find these probabilities. After that, you can simply multiply and sum these three values, right? Let's see how to find that one, right? Just consider this situation, right? What is the meaning of that one? 2 from A and 0 from B, right? That is A1, right? Right? Uh, then you can use the binomial equation. 2 from A, 0.05 into 1 minus 0.05 and means the multiplication, right? This one refers to, right? This one refers to this branch, right? Into there is no from B. This one 0, right? 1 minus zero point 0.1 is 0.9, right? That is 2. That is one option. Plus, what is the second option? 1 from A and 1 from B, right? This option, right? And, right? And refers to this multiplication 1 from B, right? What is the third option, right? You have to take all the probabilities and take sum, right? You know the probability theories, right? Third one should be 0 from A and 1 from, sorry, 2 from B, right? Then that is this option. And 2 from B, right? Those three probabilities, you have to take the summation, right? You know how to simplify, right? I will directly write the answer plus 0.0171 plus 0.009025. Answer should be 0.02815. And that's the way to find the probabilities, right? Let's see the second question, right? Second one, a company produces high quality kitchen appliance. Each day it reports about 5% defective items, right? The quality control manager selects a sample of 15 units each day to take the necessary action for the next 7 days, right? What are the information they have given, right? A company produces high quality kitchen appliance. Each day it reports about 5% of defectives, right? 5% of defectives, right? The quality control manager selects a sample of 15 units. 15 units each day, right? So let's see what is the distribution, what is the type of distribution we can use, right? Defective items. Therefore, we have only two options, right? Two options we have. One is defective, another one is non-defective, right? This probability is 0.05, right? Also, these two options are independent to each other, right? So the number of trials is 50, or the sample size is 50, right? Uh, Mutually exclusive situation or the independent situation, we have two options, right? So if such kind of situation, we can go for binomial distribution, right? Situation is buying, and that is a Bernoulli situation, and also they have two options, defective and non-defective. Those are independent, so we can go for binomial distribution easily, right? So what is the probability that non-defective items will be found on a given day, right? So the probability of success or failure, no? Success is probability of having a defective item, right? That is 0.05, right? Exactly one, right? Probability that no defective items, right? So then x should be is equals to 0, right? So the equation is like this, right? We can simply substitute the values. 0, 0.05, that is 0, 1 minus 0.05, that is 15 minus 0, right? Answer will be 0.4633, right? The part B, what is the probability that at least one defective items, right? At least one defective item. At least one defective item. Then defective items may be greater than 1, right? So, therefore, we know how to write this, right? X is equals to 0, like previous situation, right? So 1 minus 15, 0, 0.05, 0, 1 minus 0.05, 15 minus 0, right? Then you can take the answer as 5367, right? This is how to find the probability of x at least greater than or equal 1, right? So let's see the third question. At ACME Rivet and Machine Company, a process produced 20% of defective items, right? 20% of defective items, right? Quality system manager are analyzing how to improve the process. If we take a sample of 15 items, give the probability that we will find the following, right? So again, we have a binomial situation, right? We are referring as our success, right? As our success is having defective items, right? Two options, defective and non-defective. So mutually exclusive, mutually exclusive, right? Or the independent, right? Therefore, we can take binomial, right? Exactly one defective item, right? NCX Px 1 minus P n minus x, right? This one is probability of success. This one 1 minus P means probability of failure, right? According to our situation, what is P? The probability of defectives, and 1 minus P is probability of non-defective, right? N is 15, exactly 1. So 0 0.2 and the power 1 y minus 0 0.2, 15 minus 1. You can simplify, take the answer as 1, 3, 2, right? So the second part, the B part, two or more defective items. Two or more means at least two. Two or more, or at least two, right? Now you know how to simplify this one. Should be less than 1, right? So this one should be x0 plus x1, right? By substituting values to the equation, you can simply find the answer. And this one should be 1 minus 0.2 is 0.8, right? Plus 40, right? Therefore, answer should be 0.8329, right? Let's see the fourth question. The number of telephone calls passing through a TCS switchboard has a Poisson distribution with an average rate of 4 calls per minute, right? Find the probability that the switchboard receives, right? Here they have discussed about a rate of something, right? Average rate of 4 calls per minute, right? Also, we can distinguish the number of calls 1, 2, 3, 4, 5 like this, right? Therefore, this is surely should be a discrete situation, not a continuous one, right? Because we can count the number of calls, right? 1, 2, 3, 4, 5, 6 like that. therefore a discrete situation. And also they are discussing about average rate or rate sum, right? Also they have given that follows a Poisson distribution, right? In your exam, sometimes they will give the distribution or the which type of distribution of that situation, or sometimes they will not provide the distribution. Therefore you have to clearly read the question and find which type of distribution we can use to solve that question. But this question, they directly give the what is the distribution, the Poisson distribution they have used, right? If they don't give the distribution, you have to identify, right? If we have two situations like success or failure, you can go for binomial distribution, right? If the two situations are mutually exclusive or the independent, and we have two situations, you can go for binomial distribution. If we are discussing about a rate of something, then we can normally we can go for Poisson distribution, right? Then also they have given the rate, right? That is the parameter of a Poisson distribution, lambda, right? Let's see. Lambda is 4, right? 3 calls in the next minute, right? Per minute, this is per minute, right? Per minute, right? For 3 calls in the next minute, right? Next minute. What is the equation? You have to write the equation clearly. X factorial, right? E lambda is minus 4. 4 to the power 3 divided by 3 factorial, right? The probability should be approximately 1954. You can simplify this one by using a calculator, right? Therefore, part B, one or more calls in the next 2 minutes. Next 2 minutes, right? Clearly understand what is the question says, right? The previous case, average rate of 4 calls per minute, right? Per minute, they have given the average rate as 4. But in this question, they are referring one or more calls, right? One or more calls mean at least one, right? One or more calls in the next 2 minutes, right? Previously in next minute, but now in next 2 minutes, right? So definitely the average rate should be different from this situation. Lambda is equal for 1 minute, right? But now we are referring for 2 minutes. Then what is lambda? For a minute, that is 4. Then now for 2 minutes, that should be 4 into 2, right? That is 8. Right now, you can substitute values to your equation. 1 minus x is equals to 0, right? 0 factorial, right? Answer should be 0.9997 approximately, right? Right, question number 4. Sorry, question number 5, right? The quality control manager of Marian's cookies is inspecting a batch of chocolate chip cookies that has just been baked. If production process is in control, the average number of chip parts per cookie is 6, right? Also, they are discussing about averaging something, right? So they have given the average as 6, right? Therefore, we can go for Poisson distribution. Part A, what is the probability that in any particular cookie being inspected, fewer than 5 chip part will be found? Fewer. What is the meaning of fewer? That is less than 5, right? Less than 5. So you can write it as 4. I will explain the both methods, right? By using this equation, you can simplify the answer, right? By using a calculator, right? E to the power minus 6, right? Answer should be 252851, or otherwise, right? You are familiar with this one. What's the meaning of this one? This is a discrete distribution, therefore we can take from 0, right? Right, probability of x is equals to 3, and the probability of x is equals to 4, right? You can simply substitute values to the equation and find the answer, right? 2851, right? You can simplify each and every equations to find the answer, right? So the part B, for part B, what is the probability that in any particular cookie being inspected, 3 or 4 chip parts will be found? 3, 4, 4 defective chips. O. What is the meaning of O? That is plus, right? Therefore, they are asking 3 plus 4, right? So we have the equation plus, right? Now you can simplify, right? Use a calculator to simplify the equation, and that is the probability, right? So the part C, how many cookies in a batch of 100 being sampled, right? Sample size is 100. Should be manager expect to discard if company policy requires that all chocolate chip cookies, all must be at least 4, right? Here we have to answer the number of cookies uh, to discard, right? For the probability is what they are referring, at least 4, right? First we have to find this probability, right? Two, three, right? So this one should be 0, 1, 2, and 3, right? So this one should be 1, 5, 1, 2, right? You can simplify. The probability is 8, 4, 8, 8, right? But they are asking the number of cookies to be discarded, right? Here they sampled 100 cookies they have selected. Cookies, right? So we have the probability 0.8488. Therefore, we have to discuss what approximately equals to 85 of uh, cookies should be discarded, right? They have asked about number, right? We have the probability and we have the total number. Therefore, 85 of cookies should be discarded, right? So the sixth one, the number of defective items returned each day over 100 days, a shop is shown below, right? Assuming that the number of defective items may approximated by Poisson distribution, calculate the value of lambda and find the probability that, right? Let's see how to solve that one, right? They have given Poisson distribution, right? Defective items, right? Defective items, right? Over 100 days, right? So we have to find the lambda, right? They have given the number of defective items from 1, 2, 3, and 4, and greater than 4, right? And the frequency they have given, right, as 15, 20, 15, 10, 5, and 0, right? So, right? So, what is the meaning of lambda? Lambda is average or mean, right? We have frequency, observations, and the number of defective items. So therefore, the equation for the mean should be summation fx over summation f, right? So you have to simply multiply frequency with appropriate x value and the summation of these values. So that is 100, right? The summation f is also 100 because the frequency related to over 100 days. Therefore, lambda is equals to 1. For 100 days. For 100 days, we have the rate of defective items, right? no defective items is returned. Therefore, x exactly equal to 0, right? E to the power minus lambda, lambda x factorial, right? E to the power minus 1, 0, 0 factorial. Answer should be approximately equal 0.3679, right? For second part, exactly 3 defective items, right? Exactly 3 defective items, right? Answer should be 0613, right? 3 or more defective items, right? 3 or more defective items, 1 minus 2, right? 0 because this is a discrete situation, 1 plus 2, right? You can simply take the answer 0.0803, right? For part B. For part B, if the shop owner decided to follow the same procedure over 250 days, what would be the value of lambda? And we have to find the same probabilities related to part A, right? 400 days. We know 400 days lambda is equals to 1, right? We have to find for 250 days. If for 100 days lambda is 1, therefore per day that should be lambda 1 over 100, right? Therefore, for 250 days, lambda should be this much, 2.5, right? That is the way of finding lambda, because they have they have given, or we found the lambda for 100 days, that is equal to 1. Therefore, we have to find for 250 days. If we know 100 days, lambda is equals to 1. For 1 day, lambda is equals to 1 over 100. For 250 days, we have to multiply 1 over 100 by 250, right? Now we want to find x is equals to 0, right? 2.5, 2.5 to 0, 0 factorial, right? Answer should be 0.0821, right? So x exactly equal to 3, right? 2.5, 2.5 to the power 3, 3 factorial, and that is 0.2137, right? X greater than or equal to 3, right? 1 minus b, right? You know that one, right? That one should be uh, x0, x1, and x2, right? The one should be, right? So Let's see the seventh one, right? The length of a human pregnancy is normally distributed with mean of 270 days and a standard deviation of 9. Clearly start in the random variable, find the probability of a pregnancy last more than 280 days, right? Now we are in question number 7, right? So what is the random variable x? That is length of a human pregnancy, right? That is x, right? That is normally distributed, mean, and this variance 9 is cut because standard deviation is 9. For variance 9 is cut, right? So right, this is a continuous distribution. This is a continuous distribution because that is normal, right? So we want to find pregnancy lasting more than 280, right? But we have standard normal, right? Right? Just consider this one. What is the mean? Right? This is the mean, and we want to find this is 280. This area's probability we want to find, right? Right? So right, this shaded area probability we have to find, right? So but we have standard normal, right? In standard normal, right, standard normal mean should be 0, right? Therefore we have to convert this x into z, right? That is standardizing, right? You know that, right? They are asking about px greater than 280. How we can convert this one? X minus mu over standard deviation, right? Therefore, x minus mu divided by sigma. The same thing we have to do for 280 as well. Standard deviation is right. Now this one should be our z greater than. If you simplify this one, value is just consider keep at keep as it is, right? Right. Therefore, just simplify the values, right? So 280 minus 272, that is 8 divided by 9, that is 0.888, right? This one should be 0.8889. Right? As we discussed earlier, in standard normal table, we have left tail areas, left tail probability. Therefore, right, this one, if we use a diagram, this one 0, this one is consider 0.88 something. We have to find this area, right, as I mentioned earlier, right? In standard normal table, we have left tail probabilities, right? Therefore, we have to subtract this one by 1, right? 0.889, right? Therefore, that probability related to this area, right? This probability we can find by using our graph or our table, right? Let's see the table, right? We want to find the probabilities. I will share the graph or share the table with you, and right, this is the table, right? 0.88 or 0.89, right? 0.89 we want to find. 0.8 this one, 0.8 this one, 89 is 0.8133, right? We want to find the probability, right? These values are probabilities. These values are Z values, right? We want to find 0.89, right? 0.8, this one is 9, 0.8133, right? Right? This is the standard normal table, right? We are referring 0.8. This one, right? Uh, referring to 0.89, right? Right? That is 0.8132, right? This way, right? So, right? So 1 minus 0.8133, that one is 0.1867, right? Therefore, so answer should be this one, right? So the second part B, x less than 250, right? The left-sided probability they are asking, right? This one should be like 250, right? Left area probability they are asking, right? Therefore, like previous, we have to convert in a standard normal, right? 1 by 9, right? So this one should be minus 2.444, right? So this area we have 0, this one is minus 2.444, right? This area we ask, right, by using standard normal table. Again, we can go for standard normal table. So this one is the standard normal table, 2.44 minus 2 point minus 2.44 means this one, right? Minus 2.44, 0.33734, right? So this probability we can directly take, right? So this one is 0.0073, right? Because we are referring left side, right? Part C, it is between 265 and 280, right? This one should be 265 minus 72 divided by 9. This one should be Z, okay? 280 minus 272 divided by 9, right? This one should be minus 0.77, just 78, right? So this one is 0.889, right? Initially, we have our mean is 272, right? This one is considered 265. This one is 280. They are asking about this area probability, right? Now we converted that one into standard normal. Therefore, this is 0. This one should be minus 0.78. This one should be 0.889, right? This area we want to find, right? As I mentioned earlier, just consider this graph, right? 0, right? This one, right? This one minus 0.78, right? This one should be 0.89, right? We want to find this area. But in standard normal table, we have left-sided area, right? So up to this point, we can find the probability because we have so let's I will explain like this, right? As I mentioned earlier, we have left tail probabilities in our table, right? So in standard normal table, first we won't find if the probability from negative infinity to this one, this 0.89, right, indicating this total probability, right, from negative infinity to 0.89 indicate this probability, right? Right, total probability. First, we have to consider that one, right? So let's see the table, right? So that probability 0.89. Just consider 0.89. 0.8 this one, 0.89 mean 0.81327, right? Just consider that value 0.8133 from negative infinity to this point. This total area, right? From negative infinity to negative 0.780, indicating I will use a different color, right? Indicating this area, right? That value also we can find by using the table, right? Because we have the left-sided one, minus 0.78. 0.7 we have here. 7, 8 means this one. 2177. Right? This is 0.2177. Right? This area. But we need which area? We need this area. Right? This area we need. Right? We have this total area as 0.8133, right? We have this portion, the red color portion, we have 0.2177. So, right? So if we want to find the green color area, right? We have total this one, and red color area this one. If we subtract these two, you can definitely find this area, right? Therefore, 0.8133 minus 0.2177, right? The answer should be 0.5956, right? Therefore, in such kind of situation, right, probability of minus 0.78 is at 0.89, no? 89 we want to find. So, if probability, sorry, not x, that is z, right? Right, that one should be z, right? Z, right? Z less than 0.89 means this total, right? Minus z less than minus 0.78. 78 means this red color. By using this one, we can find this one 0.833 minus 0.2177, right? 0.5956. That is the answer, right? Let's see the part D. What is the part D of that question? The length of pregnancy that 10% of all pregnancies last, right? Here they have given the probability, right? We don't need to find the probability. The previous A, B, and C part, we found the probabilities, right? They have asked to find the probabilities, but in part D, right, they have given the probability. Then we have to find what is the value of X, what is the value of all pregnancies last, the time, right? X variable, right? In the first parts of that questions, what is the X is? That is, X is the pregnancy of human, right? Therefore, they have given the probability as 10%, right? Probability as 10%, right? So part D, probability they have given as 0.1 or the 10%. Now we want to find the value of X, right? We have standard normal, right? If we take the standard normal, that probability is equals to 0.1. Probability is equals to 0.1. We have to find this X value, right? They have given the probability. Part A, B, C, we found the probabilities with the given information. Now they have given the probability, right? We have to find the value of X, right? As we discussed earlier, right? As we discussed earlier in the standard normal table, the middle values are probabilities, right? Middle values are probabilities. So we want to find if the Z value, right? You can see here, these are the probabilities, right? These are the probabilities, right? These are the probability, these are the Z values, right? To find the appropriate X value, first we have to find the Z value. After that, by using this equation, right? By right? First, we want to find the Z value. This one is refers to Z no, right? This one is Z. They have given the probability. We want to find the Z value related to this 0.1 probability. After that, by Z value we have, then we can simply uh, equate this part to that Z value, we can find X because we know mu and sigma, right? First, we have to find the appropriate Z value related to this 0.1 probability, right? So let's see, where is the location of 0.1? You can see here, the value is 0.1 is somewhere here, right? Just consider the value is minus 2.3 between these two values, right? Between these two values, the 0.1 probability, 0.01, right? The 10 percentage means 0.1, right? 10 percentage is 0.1. Let's see this one, right? Between these two, right? There, that one is between 2 minus 2.3, 3, 2.3, 2 and 3, 3. Right? Between these two, no, you can take the average, or you can just consider that value, value 0.1 is here, right? 2.33, right? Minus 2.33, right? Therefore, the Z value is minus 2.33, right? 33. So Z value related to this probability is minus 2.33. We can write it like this, right? P inverse, right? X minus mu divided by sigma is equals to minus 2.33, right? Now we know the Z value, right? We know the Z value. So that is minus 2.33, right? We can equate this one. Mu is 272 divided by 9, right? Now you can simplify this one. You can take the answer as 251.705. Therefore, approximately the pregnancy lasts 251 days when what is the question, when the probability is 10%, right? That is how we can find the X value if they have given the probabilities, right? The question number 8, find each of the following probabilities where Z is score from the standard normal distribution with the mean mu and standard deviation is 1. They have given the standard normal values. We want to find the value. This is very easy. You can use your standard normal table to find the values, right? Also, another important thing is this, here consider the previous case that 0.1 probability, right? 0.1 means, right, somewhere here, right? This is refers to the question number 7, right? This one is 3, no? Then the total probability always equals to 1, right? Total probability is always equals to 1 mean from negative infinity to positive infinity. That the area under the curve, this area I will use a different color, right? This total area, the total area always equals to 1, right? Therefore, if we use the mean value, between the mean value, right, if the standard normal, right, if we the graph correctly divide into two parts by using this mean value, right? If the total probability is equals to 1, this part should be 0.5, this one should be 0.5, right? But in the question says that the pregnancy that is for 10 percentage means 0.1, right? 0.1 mean somewhere here, right? Somewhere here, this area should be this area. This one should be 0.1, right? This area we want to find, right? So I will explain again with another questions, right? For question number 8, right? We can use the standard normal table directly to find the values, right? Right. So P is it less than 2.36, right? It is easy to draw a graph, right? Use graphs. Then you can simplify the answer 2.36, right? 2.36, we want to find this area, right? We have the left-sided area in our graph as well. So you can simplify 2.36, right? 2.36 mean positives, right? 2.36. This is the 2.3, right? 2.36. This one. 2.36. 6 is here. 9986, right? 2.369986 here. This value should be the answer, right? You can directly use. With the table, sometimes the value slightly different, right? 9806, right? So the way of finding the value is same, but the value is sometimes slightly different by tables, right? So part B, that is the part B. Part B is Z greater than 0.67. What is that? 0, this one is 0.67, right? This area we want to find, right? But in the table we have the left-sided one. So, but in the table we can find this area by using the table, right? This area, if you want to find that one, you can simply take 1 minus Z 0.67, right? That is refers to your this area 1 minus up to 0.67 related to this shaded one, right? So 1 minus 0.67, right? The same way you want to find by using your table, right? The answer should be 0.2514, right? So the C part, 0 is at 2.11, right? As we discussed earlier, right? This one should be 0, right? 2.11 means this one. This area we want to find, right? In a standard normal table, as I discussed earlier, right? We have the left sided area, right? From negative infinity to 2.11, right? This area we can find this total area, right? Negative infinity to 2.11, right? So this one by using your standard normal table, right? 2.11. 2.1 is here. 1 is 0.98224, right? So this one, how we can simplify this one? Z less than 2.11 minus Z less than 0, as we discussed earlier, from negative infinity to this one and negative infinity to 0, right? For Z less than 2.11, that is 0.9826, this total area, right? This red color area is 0.9826, right? So Z less than 0 means from negative infinity to 0, right? Right? This area, right? That value should be 0.5. You can refer the table, right? Therefore, we have this total red color area is 0.9926 and this area is 0.5. Then if we subtract these two values, we can take the green color probability as 4826, right? In part D, part D, 78 is at 0.97, right? Just to refer your graph, right? Always try to draw the graph and find the answer. That is much easier, right? You don't make the mistakes, right? We want to find this area. As we discussed earlier, from Z, 1.97 minus Z minus 2.78, right? This one should be 0.9756, that is total area, minus 0.2227, right? This is this area, right? Then the total area equals to this one. If we subtract those two values, we can take this area, right? That should be 0.9729. Right, let's see the question number 9. Right, let X be a normal random with the mean 15 and the variance is 2. x normally distributed with mean high and right. So x we want to find a px, right? First we want to convert this one into standard normal as previous, right? Divide by square root of 2, right? Its answer should be uh, z less than 3.4, 3.54, right? This one should be 3.54. We want to find this area at left sided area. By using table, you can find, right? I want to say that in some situations, this 3.5 we cannot find by using a table, right? Because in some tables, sorry, in some tables, we have only 3.4 up to 3.4, right? But we want to find 3.54. You can see here 3.49 is 0.99976, right? That is approximately equals to 1, right? Just consider our table have only 3.4, right? The greatest probability is 0.9976. Therefore, we are going to take that one. That is okay, right? Also, you can write the probability as 1, right? Almost 1 because the value is very much near to 1, right? 0.99976, right? So just consider our table only 3.4, right? So you can use in questions in your final exams, there may be definitely less than 3.4, right? So that one should be 0.9998 something, or you can write it as approximately equals to 1, right? So the part B, x greater than 20, right? This is 20 means mean is what? That is 15. This one is 20. This area we want to find, right? First, we want to convert it into standard normal. We said 20 minus 50 divided by, again, the same problem we can fix, right? He said greater than, this one should be 3.54 no? Then 1 minus, he said 3.54. Right? 1 minus should be because the greater probability. On the table, only we have this probability. Right? Again, 1 minus 0.9998. Right? That one should be approximately 0.0002, approximately 0. Right? So, the part C, right? Part C, that is 10x 20. Right? So first we want to convert this into standard normal, right? This one is 10, this one is 20, right? We want to find this area, right? So if we convert this one is minus 3.54, is a 3.54, right? So this one is like this, right? 0 minus 3.54, 3.54. This area we want to find, right? As we discussed earlier, we can find by simplifying this equation, right? That is very easy, right? So this value initially we found that one minus 0.0002, 0.9996, right? For part D, x less than or equal 15, right? Means that our mean value is what? That is also 15, we asking about this probability, right? Definitely this one should be 0.5. Let's check, right? In continuous distribution, right? Continuous distributions, right? Less than or equal, less than, greater than or equal, or greater than, those are equal. No confusions. You can directly use less than or equal, or less than, greater than or equal, and greater than, those are same, right? No confusion. You can directly use, right? So this one should be, this one is at 15 minus 15 divided by square root of 2, right? Now this one should be 0, right? This probability we have to find. If we check the table, right? We check the table, you can see here the probability 0 is 0.5, right? Therefore, this probability is 0.5. Right, that one is easy, right? Part E, right? We have the mean value is 15. This one is 10. Greater than area means this one we want to find, right? First, we want to convert into Z, right? This one should be minus 3.54, right? This 3 point minus 3.5 also normally in table we can't find, right? In some table we can find, right? Therefore, this area we want to find. This one should be minus 3.54, right? This area we want to find, as I mentioned earlier, we have only right-sided area, therefore 1 minus is at less than or equal to 3.54 minus, right? Then the answer should be, right? Answer should be 1 minus this area, and this probability we found in previous equations, right? 0.332, 0.9998. At almost all the probability, right? So let's see the 10th one. The 10th question, right? What is the question they have given? Is a disco corresponding the given area? Okay, right? They have given the probabilities here, right? Probabilities they have given. We want to find the value of x. No, it's a disco, not value of x. We want to find the z score. Let's see how to do that one, right? Area, the probability is 15%, right? As I mentioned earlier, total probability under the curve, right? Total probability is equals to 1, right? So the finding, we want to find 0.15. You can see here from negative infinity to positive infinity, from this side to this side, total probability is equals to 1, as I mentioned earlier, right? So this part is 0.5, this part is also 0.5, right? If we are referring 0.15, that one should be somewhere here, right? This is this probability is 0.15. 0.15. So they have given the probability, right? They have given the probability. We want to find the Z value, right? You can go for your table, right? You can go for your table 0.15. You want to find the location of 0.15. Let's see, 0.15, definitely a negative value, right? 0.15. 0.15. 0.15 is 1.0 somewhere here minus 1 point this one. Just consider this one. You can take approximated value 0. Sorry, minus 1.003, right? That should be the answer. Definitely a negative value because uh, definitely negative value, negative side. This one is negative side now. Therefore, this one, this 4 is minus 1.03, right? So, right? If we have mu and the standard deviation, we can find the x as well. In that previous questions, we discussed those things, right? But here we want to find only z value, right? The part B, what is the question? The question is the area to the right of z is 65%. 65% of the graph covered, right? This one is 0, right? This one is from 0.65. Oh, sorry, I made a mistake. I will explain it again. The question says what? The question says, right? Question says the area to the right of z is 0.65. To the right, 0 of z is 65%. To the right means this right side. This area is 0.65. This one should be 0.35. Right? So from negative infinity to sun is negative infinity to this is it. We can find, right? From right, you can use your graph. Sorry, the table, right? 0.35. That is the location of 0.35. You want to find 35. Definitely a negative value. Right, you can see here the table minus 3 point. This is somewhere here, right? For 0.38, right? Let's consider that value 0 point, right? Set this 0.38, right? We want to find this location. This area should be 0.65. So the total probability is, right? Total probability is 1, right? Then we want to find the 0.35. If we find this value, because we have the left-sided one, then we can find the location of Z, right? So part C. The area to the left of Z is 10%. left side. They are referring left side. This area is 10 percentage, then this area is 90%. So we have a left-sided graph or the left-sided table. So just consider the probability is 0.1, right? So we have to find the location of 0.1. Let's see, 0.1, right? Definitely a negative value. 0.1, this one, minus 1.28. Minus 1.28, because the question clearly says that what? Area to the left of Z. Left of Z is 10%, right? So part D, the area to the right of Z 0.5, to the right side. They clearly mention that, right? This area should be 0.95, right? We want to find, sorry, this Z, right? As I mentioned earlier in our table, we have only left side, right? Left side. Therefore, we want to find the location of 0.95 from negative infinity to Z. This point Z, the probability is 0.95. The area under the curve is 0.95. So we want to find Z. So by using the table, you can find the location of 0.95. Let's see, right? 0.95, the value should be definitely a positive value, right? So 95 is 1.64 or 1.645. That is a very famous value, right? So Z value, right? The Z value is 1.645, right? It covers this total area, right? So the part E, the area between minus Z and the plus Z is 95%. Minus Z plus Z. This total area is 95%. This one should be 2.5% because this one is a symmetric distribution, right? You know that one. So we want to find minus Z. Directly we can find by using your table, right? 0.025. Let's see. 0.025. That is also a very famous value, right? You know that one, 0.025. Right, you can see here 0.025 minus 1.96, right? This one is minus 1.96, right? It covers negative infinity to this point, right? And this area should be what? From negative infinity, so negative infinity to this one. Total area should be 95 percentage plus 2.5 percentage, and that one should be 97.5, 0.975, right? This probability is covering this total area, right? So we want to find the location of 0.975 by using your table, right? 0 point, definitely a positive value, right? 975. 975. Where is 975? You can see here 975, 1.96, right? That is a positive value, right? 1.96, right? That is the way of finding the disco value. If they have given x, not x, they have given mu and sigma, then we can find the x as well, right? So that is the end of the tutorial number 4 related to fundamentals of statistics for technology, right? Thank you very much.